Hey class, Mr. Handry here. For today's lesson, we're going to be taking a look at section 11.4, which is going to do with angle-angle similarity of triangles. Now, for today's lesson, we have one learning goal, and our learning goal for today is that you will be able to prove two triangles are similar using the angle-angle similarity theorem. So that is our goal for today, and what we'll be taking a look at. Now, angle-angle similarity is going to be similar to when we talked about congruence shortcuts. So, for example, angle, side angle, side, 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 HL, or AAS. When we talked about proving two triangles congruent, we can use angle-angle to prove that two triangles are similar. And we'll talk about a couple others when we get to the other side. But first, we just want to take a moment and talk about angle-angle. So for angle-angle, it states, if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. So if you can say that two angles are congruent to each other, two corresponding angles are congruent to each other. So for example, in this diagram, if I can say that angle A is congruent to angle X, and if I can say that angle B is congruent to angle Y, then I can say that these two triangles are congruent. ABC, XYZ. So, angle-angle similarity allows us to say if we know two angles are congruent, then we know the two triangles are similar. If we know the two triangles are similar, then we can use the fact that angles are congruent and side lengths are proportional to find lengths of side lengths. So, with that said, we'll get into identifying angle-angle and other ones later. But first, we want to find the indicated length when we're given two different triangles, if possible. So if we look at example 1, Example 1 wants us to go through and find the indicated length for each problem, if it is possible. So we're going to use this idea of determining if the triangles are similar using angle-angle. If they are, then we need to go through and find the length of BE, RT, and so on using proportions because side lengths are proportional. So if we look at A, okay, can I say that these two triangles are proportional? Okay, I can, or similar, because if these two lines are parallel and they're cut by a transversal, I know by alternate interior angles that A is congruent to D and that C is congruent to E. So based off alternate interior angles, because I have two parallel lines cut by a transversal, I can say that these two triangles are similar to each other. So I do know that triangle ABC is similar to triangle DBE based off of angle-angle similarity. Now that I know that, we need to go through and figure out the length of BE. So BE is going to be this side length right here, and that is our goal to hopefully figure out. Now, BE is going to be the last two letters of the second statement. So the last two letters of the first statement are BC. So we're going to set up a proportion of BC over BE equals, and then we're given the fact that AB is 36 and that BD is 54. So AB and BD are both the first two letters in each statement. So we're going to set this equal to AB over BD. So I now have my proportion. Now that I have my proportion, we can go through and plug values in. Okay, we're told that BC is 54. And we need to figure out what BE equals. So we're going to leave that as BE. And that's going to equal AB is 36. And BD is 54. So now that I have 54 over BE equals 36 over 54, we're going to go through and cross multiply and then divide to solve for BE. So first step is we're going to do 54 times 54. So when we do 54 times 54, we're going to end up with 2,916. And that's going to be equal to 36 times BE. And then all we have to do from here is just divide. So we're going to do 2,916 divide by 36. And we're going to end up with 81. So that means BE is 81 units long. So after you have figured out that the two triangles are similar, then you can go through and set up proportions with the side lengths, cross multiply and divide to find the missing length. So with that said, let's go ahead and take a look at B for further practice. First of all, they tell me that S and T are congruent to each other, and then I know that angle R is congruent to angle R based off the reflexive property. So I do know that triangle RSV is similar to triangle RTU. So triangle RSV is similar to triangle RTU. So that's going to tell me my two triangles are similar from angle-angle. Now that I know that they're similar, we can use this idea of proportional sides to figure out the length or the measure of RT. Now, RT is going to be the first two letters in the second statement. So the first two letters in the first statement are going to be RS. So it's going to be RS over RT. We're told that RS is 10, and we need to figure out what RT is. So the other side of the proportion needs to come from two side lengths that we know the measure of. They tell us that SV is 8 and TU is 12. So we're going to do SV over TU. So it's going to be 8 over 12. So now that I have 10 over RT equals 8 over 12, all we need to do here is cross multiply and solve. So if we go through and use our calculator, if we do 10 times 12, we're going to end up with 120. And then if we do 8 times RT, we get 8 times RT. So then lastly to solve, all we need to do is take 120 divided by 8. And we end up with RT equaling 15. So the length of RT is 15 units long. And that is how you do example 1. So you do the same thing for parts C, D, and E, where go through, first of all, determine using angle-angle if they are similar. Once you know they are similar, you can go through and set up the proportions. So With that said, let's kind of run through a few more just for practice and for reference. So if we move on to C, for part C, they want us to figure out the length of AB. First of all, because these two lines are parallel, and we can say cut by a transversal, I do know that D and B are congruent to each other based off corresponding angles. And you can say the same for E and C, or we could just say that A is congruent to itself based off the reflexive property. So that tells us then that triangle AED is similar to triangle ACB based off angle, angle. Alright, so now that I know the two triangles are similar, we want to go through and find the length of AB. So AB is the first and last letters of the second statement. So the first and last letters of the first statement are AD. So it's AD over AB equals, so if we have AD as 6 and then AB is going to be the value we want to find, then we're told ED and CB are 9 and 15. So we're going to use ED over CB. So now that I have my proportion set up, we're just going to plug the values in. So AD is 6 feet. We want to figure out AB. And then we're told that ED is 9 feet and CB is 15 feet. So we're going to cross multiply and divide, and we would get AB to equal 10. And that is our answer for part C. Now, if we take a look at D, so they want us to figure out PQ. So for PQ, that's going to be this little length right here. So to go through and set this up, we first need to figure out if these are similar. Well, first they tell me that T and P are congruent to each other. Then they tell me that S is a right angle here. And because this is a straight line, that means this is also a right angle. So that means that I know these two triangles are similar based off angle, angle. So since I know that these two triangles are similar, then we can go through and solve for PQ. Little slight caveat on this problem. Okay, PQ is this little segment here. Okay, but we're going to go through and figure out this entire length right here to figure out with PQ. So, first of all, I know that SR is 12, and that's going to relate to this side of QS. So we're going to have QS over SR, and then we're going to have TS over PS. Alright, so now that I have these parts set up, what we're going to go through and do next is plug in our values. So we know that QS is 9, SR is 12, we know that TS is 15, and then we're going to figure out the length of PS. So I'm going to figure out the whole length of PS first, Once I've figured out this entire length, if I know that PS equals PQ plus QS, this whole thing, that means all I have to do is take whatever I figure out for PS, subtract it by 9, because that's going to take that part away and just leave me with PQ. So if we go through and solve for PS, we do 12 times 15, we get 180 equals 9 times PS, and then we just divide by 9, and we end up with 20 equals PS. So the entire thing of PS is 20. So if this whole thing is 20, to figure out PQ, all we have to do is just do 20 minus 9, and that's going to tell us that PQ is 11. And that is your answer to part D. All right, last one to run through, which would be E. Quickly, to determine that these two triangles are similar based off angle-angle, we know that A and C are congruent because they told us, and we know that angle E is congruent to itself based off the reflexive property. Now, they want us to go through and figure out the length of AC, or in this case, Y. So we need to figure out that length. To go through and solve this, okay, we're going to set this up much like we did this, where we're going to take the known stuff, so AB over CD, and we're going to set that equal to AE over CE. So what we're going to do is figure out the whole length of AE. Once we have that whole length of AE, all we have to do is just subtract away CE, and that's going to leave us with Y. Because 8 plus Y is going to equal whatever AE is. So if we just subtract 8 away, that tells us what Y equals. So if we go through and plug all of this in, AB is 14, CD is 10, then we need to figure out what AE equals, and then we know that CE equals 8. So if we go through, if we do 14 times 8, we end up with 112. And then that's going to equal 10 times AE. If we divide 112 by 10, we're going to equal 11.2 for AE. So it means this whole length right here is 11.2. So if we know the whole thing is 11.2 and this part is 8, to figure out what the other part, y equals, we're just going to take 11.2 and subtract it by 8. And that is going to tell us that AC, or y, is going to equal 3.2. And that is our answer for part E. And that is how we go through and do example 1, where we find the indicated length using Angle-Angle Similarity Theorem, because we went through and proved that all 5 of these triangles were congruent based off angle-angle. Once we knew that they were similar, and we've proved them to be similar, then we could use the property of similar triangles where the side lengths are proportional. So we set up our proportions, cross-multiplied, and solved. So that is how we do example 1. Next, I want to take a look at example 2, which is going to have us determine if triangles are similar, not only using angle-angle, but also two others, which are going to be side-side-side and side-angle-side. So, side-side-side is going to sound very similar to what we talked about with side-side-side congruence. Okay, it's just in this case, not all three sides are congruent, yet if three sides of one triangle are proportional to the corresponding sides of another triangle, then the triangles are similar. So instead of being congruent, we need all three sides to be proportional. So that's where you would go through and figure out the proportion for all three sides. If you get the same number for each set of sides, then you know that that triangle is similar. The other way would be if we knew that two sets of corresponding sides were proportional and the included angle between those two sides were congruent, then you could say based off side-angle-side triangle similarity that they were similar. So 3 ways you can state that triangles are similar. Either angle-angle, where you know that two angles are similar. Side-side-side, where you know that all three sides and their corresponding sides are proportional and they have the same proportion. Or side-angle-side, where you know that two sets of sides are proportional to each other and the included angle. So that's what we're going to do for example 2, is go through and determine if these triangles are similar using one of those 3. So first of all, for A, the first thing, by looking at our diagram of triangles MNP and then MRQ, is they first of all tell me that this angle is congruent to that angle. So they tell us that angle NMP is congruent to angle RMQ. So I know that these two angles are congruent because they gave me that information. Now, quick and easy thing would be if we knew anything about any of the other angles. I don't unfortunately know anything about angle N or R or P or Q. So I can't use angle-angle because I already have one angle congruent. The next best thing would be to use side-angle-side. So what I need to do is figure out the two sides that are going to include the angle if they are proportional. So that's going to be NM and MP, and then RM and MQ. So that's what we're going to set up first. So if we start with NM over MR, NM is going to be 4, and MR is 6. So if we have 4 over 6, 4 over 6 is going to simplify down to 2/3. So that's my scale factor, or my proportion, for these two side lengths. Now next, we have to figure out for MP and then MQ to determine if they are proportional to each other. So if we have MP over MQ, MP is 8, and then MQ is the whole thing, so that's going to be 8 plus 4, so it's going to give us 12. So 8 over 12 is going to simplify down to 2/3. So I know that both sets of sides are proportional to each other. So because I know that these two sides are proportional to each other and that the angle included between them, I can in fact say that they are similar by side-angle side similarity. And that is our answer for example 2, part A. And then we're just going to run through the same idea for parts C and D. So, with that said, let's go ahead and take a look at part B. So for part B, we have triangles JGH and then MLN. So we aren't told anything about any of the angle measures in either of these triangles. So our goal is going to be to determine based off side, side, side whether or not these two triangles are similar. So we need to go through and figure out if all three sets of sides are proportional to each other. And if we can do that, then we can say they are similar based off side, side, side. So first up, we are going to start with the side length of GJ, and that side is going to correspond to LN, because I'm taking the two smallest sides. So if we have GJ over LN, we have 4 over 6, and 4 over 6 is going to simplify down to 2/3. Next, I'm going to take our middle length, or the second to smallest. So that's going to be GH as 8, and then we're going to take ML at 12. So if GH is 8 and ML is 12, it's going to be 8 over 12. And 8 over 12 is also going to simplify to 2/3. So I've now proven that two sides, or two sets of sides, are proportional. So we have to go through and prove that the third set is proportional as well. So we're going to take this JH and determine if it is proportional to MN. So we're going to have JH over NM. So it's 10 over 15. And 10 over 15 is also going to simplify to 2/3. So, because all three sets of sides have the same proportion of 2/3, that means that all three sides of one triangle are proportional to all three sides of another triangle, which allows me to say that these two triangles are similar by side, side, side similarity. And that is your answer for part B. So, all of example 1, all of those triangles, those 5 triangles for parts A through E, were all able to be proven by angle-angle, where all you had to know was two angles were congruent, and you can use reflexive property, where if they share that same angle. You could use vertical angles, where two straight lines cross and opposite angles are congruent, or alternate interior, or corresponding angles to help you, or if they tell you the angles are congruent. So the first one is angle-angle. We don't have any for example 2, as example 1 was all angle-angle. And then we went through and talked about using side-angle-side, where an angle is congruent, and then the two sides that include that angle are proportional. And we also talked about side, 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 where all three sides have to be proportional for the two triangles to have to be similar. Now, parts C and D are very similar to parts A and B. I am going to leave those two for you to run through on your own if you like some practice. They are done on my completed notes if you want to take a look to see how I did those. So, with that said, that wraps up our lesson for section 11.4. And just to make note that 11.4 is the end of module 11, which typically means that we have a quiz upcoming. So be on the lookout for that. So with that said, that is all that I have for you guys today. Thank you for listening. As always, if you have any questions, just let me know via email or next time you see me. And I'll be more than happy to answer questions, whether homework or notes, however I can. So reference back during the homework or look at my completed notes for some extra guidance. Otherwise, that is it for today. Thank you for listening. Have a great day, and I will talk to you guys later.